All right, let's talk more about complete graphs. And just establish some basic facts about them, and then also talk about how do you take the complement of a graph. All right, so really the sort of the notational format for these, as you probably would have guessed from the last video, is the capital K, which I believe is comes from the German for complete, spelled with a K, and a subscript for the number of vertices in there. All right, so we'd like to make a few statements here. So Kn has how many edges? We can always answer this question. So let's figure out the answer here. All right, so I would actually say here's another place where sum of degrees is incredibly important. So let's actually answer a few other sentences and then come back and fill that in. So every vertex in Kn has degree what? So I think you figured out. All right, every vertex is connected to every other vertex, and so there are n minus 1 other vertices, and so it has degree n minus 1. All right, the sum of degrees, if I was to add up the degrees of all the vertices, well, I do n minus 1 plus n minus 1 plus n minus 1, and I'll do this n times, right? So it's n times n minus 1. All right, I know this is equal to 2e, so 2 times the number of edges is n times n minus 1. So the number of edges should be n times n minus 1 divided by 2. And so that's the answer. That goes here. You don't have to memorize this. If you know how to do your sum of degrees, you can always figure it out again, right? So I would say it's better to know the sum of degrees theorem than it is to memorize another fact. All right, let me actually finish putting this in a box here just so it doesn't look so odd. You should also note we did counting problems as well. So we can actually solve this using a sort of a combinatorics approach in the sense of from the counting side. Right, so Kn has vertices, and every edge connects together 2 distinct vertices. And given any 2 distinct vertices, there's an edge for that. So this is equal to n choose 2. Right? And vertices, choose 2 of them, you get an edge. So there's a direct connection between edges and pairs of vertices, and that's correct. The number of edges is n choose 2. Okay, so you can check that out, make sure that's correct. That is absolutely the case here. All right, so that's just an important thing to kind of be aware of. Sometimes it's just really important to know the degree of every vertex in Kn is n minus 1. Sometimes it's a simple fact like that that you need to work things through. All right, let's look at complements of a graph. So, graph complements, and this is, I need to say it, the book doesn't need to anymore. This is only appropriate for simple graphs. So, simple graph complements of simple graphs. And I'm a horrible speller. One thing I remember is the complement with an I is something you say that's nice to someone. Complement with an E means the other part or something like that. Well, I think they have similar etymology. I'm not sure. All right, so I could have this wrong too, because like I said, I'm a horrible speller. But complements of a graph. All right, so let's look at a graph G and take its complement, and it's kind of a pretty straightforward procedure. All right, so what I'm going to do is my graph is going to look like this. Okay. All right, just for discussion purposes, I'm going to label my vertices. And then I want to show you how to find its complement. I always find complements on the original graph. Here you go. There are tons of notations for graph complements. Fortunately, that's the way it is. My favorite would be C for complement, but I believe the book uses G with an overbar. There are some others too. You could use a tilde. Sometimes it's usually because one of these other notations is used up for something. My C does not look like a C. Make it look like a C. There you go. So I like C for complement. So that's my favorite. I believe the book uses an overbar. Alright, so to find G bar. Well, here's what I do, is I need to know the following fact, that G, I'll talk about graph addition in a second. So you'll see me actually doing it. If I add a graph and its complement together, whatever that addition would mean, I end up with a complete graph, Kn, where n is the number of vertices in each graph. Okay. Alright, now for graph, let me explain graph addition real quick. For graph addition to occur, you need a couple things. First of all, you need the same number of vertices. The second thing, not only do you need the same number of vertices, but you need an idea of which vertices are the same, right? So if I'm talking about G bar better have an A, B, C, D, and E. Okay, and if I add them together, what I do is I simply just glue the vertices together as they're labeled, and whatever graph I get is what I get. If there's a double, if B and D are adjacent in G, and B and D are adjacent in the other graph I'm adding to it, I don't usually make a redundant connection. But you could keep it, so I don't want to rule that out. It just depends on your definition that you're going to use. But you'd either keep it or remove it. The book would remove it. I would keep it. So there's the difference there. But let me show you how to do G bar. G bar is a specific graph, and it is what is missing. So A, I just go through vertex by vertex. A is missing its connection to E. It's missing its connection to D and to C. Everything else. Notice that this graph has 5 vertices. So I should expect every vertex to have degree 4 when I'm done, when I put together both my orange and bluish-green lines here. C is missing its connection to E, so I'm going to get that. D is degree 4, that's pretty good. E is missing its connection to B, so I'm just going to go straight there. There we go. Okay, so G bar, the complement, is the thing that I drew in orange here, and I can just pull that off. I'm just going to kind of copy it off to the side here, so you can see it's kind of isolated from this mess here. So G is its original in green, bluish green. Sorry, that's E. Let me stop talking for a second, just draw. D, B, see A is connected to its C, E and D. E is connected to B. What else am I missing? E is connected to C. I think that's it. Notice I crossed edges here, but I didn't cross them there. I could do that. I could just go through here and cross through, right? But I didn't need to, so I didn't. Remember, it's not how you draw the edges, it's their existence or non-existence that's important. So G is the original, and there's G bar. Right? These are really easy to do. I know it always seems complicated about these. You'll have more questions with complements in there, but it's just what's missing to make the graph complete. Right? So either a graph is complete or it's coming up short, and that is missing some edges. What's missing is the complement. All right. Graph addition. Again, the book would collapse multi-edges together. I would vary my approach depending on the context. Context is everything in graph theory. Depends on what you're trying to do, and then you just make your appropriate definitions from there. So just keep in mind that's not unusual. Always ask, what's the definition of what you're doing? So in this case, I'm using this to define complements, so we're not doing anything extravagant. All right, but do ask questions if you want more information about graph addition. I'll definitely do more of it. All right, so that's it for this video. The next one, we're going to start talking about planar graphs. But until then, I'll see you in the next one.